Welcome to Scientific Thoughts with new interesting episode. The Voyager space probes, launched in 1977, represent one of humanity's most impressive feats in space exploration. Built by NASA, these twin probes, Voyager 1 and Voyager 2, were designed for a mission initially expected to last only a few years. They were tasked with studying the outer planets of our solar system, sending back images and data that were groundbreaking at the time. However, as their missions unfolded, they vastly exceeded expectations. Decades after their launch, the Voyager probes are still sending data back to Earth, providing valuable insights even as they drift beyond the solar system into interstellar space. For nearly 50 years, the Voyager probes have continued their mission, collecting and transmitting data from the furthest reaches of space. Their journey beyond the known boundaries of our solar system has offered scientists insights into uncharted cosmic regions. However, the long journey has taken its toll. Both probes are showing signs of aging and deterioration. Recently, it seemed that Voyager 1 might stop transmitting data altogether due to a severe technical problem. Fortunately, NASA managed to restore the probe's functionality, buying some additional time. But this incident served as a reminder that the mission, as extraordinary as it has been, may soon come to an end. The Voyager probes were launched as part of NASA's ambitious plan to explore the outer planets. Voyager 1 was launched on September 5, 1977, shortly after Voyager 2, which launched on August 20, 1977. These launches were strategically timed to take advantage of a rare alignment of the planets, which would allow the probes to visit multiple outer planets by using gravity assists to speed their journeys. This alignment, which occurs roughly once every 176 years, enabled the probes to make close flybys of Jupiter, Saturn, Uranus, and Neptune, studying each planet and its moons in unprecedented detail. Voyager 1 was initially directed towards Jupiter and Saturn. During its approach to these gas giants, it provided humanity with its first close-up views of their moons and rings, sending back thousands of images and a wealth of data. Voyager 2, following a slightly different trajectory, extended the mission by making flybys of Uranus and Neptune. The images and information gathered by the Voyagers transformed our understanding of the outer solar system, revealing details about planetary atmospheres, ring systems, and moons that had previously been unknown. After their primary mission was complete, both probes continued on a new journey, the interstellar mission. This next phase aimed to study the outer limits of the Sun's influence, known as the heliosphere, and to reach interstellar space, the vast region between stars. Voyager 1 achieved this milestone in 2012 when it crossed the heliopause, the boundary where the Sun's solar wind meets the interstellar medium. Voyager 2 followed suit in 2018, providing a second perspective on this rarely observed transition. By venturing beyond the solar system, the Voyagers became humanity's first ambassadors to interstellar space, sending back data about a region that no other human-made object has ever visited. The longevity of the Voyager mission is an extraordinary accomplishment, especially considering that these probes were designed with 1970s technology and expected to last only a few years. Nearly 5 decades later, they're still working, although their equipment is deteriorating. With each passing year, new technical issues emerge, and NASA engineers are continually finding creative solutions to keep them operational. One of the first signs of trouble occurred in early 2022, when Voyager 1 started sending back strange, unintelligible data. At first, NASA scientists were puzzled because the probe seemed to be functioning correctly. The data it sent, however, didn't make any sense. It took several months for the team to trace the problem to Voyager 1's attitude control system, which had tried to route data through an onboard computer that had been shut down for decades. Although the scientists never fully understood why this misrouting happened, they managed to instruct Voyager 1 to send data back to the correct computer, restoring the flow of data to normal. Soon after resolving this issue, Voyager 2 encountered a problem of its own. An incorrect command caused the probe's antenna to misalign by just 2 degrees. This slight misalignment meant that the data Voyager 2 sent back to Earth was missing the planet, essentially missing the target. To solve this, NASA engineers had to use what they referred to as an interstellar scream, a powerful signal broadcasted over great distances to reach the probe and correct its alignment. However, this signal took over 18 hours to reach Voyager 2, which was 19.9 billion kilometers away. Then, it took another 18 hours to confirm that the problem had been fixed. Finally, after a tense 37-hour wait, NASA received the signal that Voyager 2 was once again aligned with Earth. In November 2023, Voyager 1 experienced another critical failure. This time, it couldn't correctly send data to Earth, and the cause was more complex than previous issues. The problem lay in the Flight Data System, FDS, the computer system responsible for collecting and organizing data from Voyager's instruments before transmitting it. Specifically, a defect in the FDS prevented it from properly preparing the data for transmission. As a result, the Telemetry Modulation Unit, TMU, which sends the data to Earth, only transmitted meaningless sequences of zeros and ones. NASA engineers spent several months analyzing the issue and eventually pinpointed the problem to a microchip in the FDS. This chip was responsible for processing data, and its failure disrupted the entire system. Replacing the chip wasn't an option because the Voyagers are far beyond the reach of human repair missions. Instead, the team had to find a workaround. They decided to rewrite parts of the FDS program, storing smaller fragments of the program code in various parts of the FDS to work around the defective chip. This painstaking solution required careful adaptation of the program to make sure each fragment could be accessed in sequence. In April 2024, after months of troubleshooting, NASA announced that Voyager 1 was back online and transmitting data again. This repair was a triumph for the Voyager team, who had once again managed to solve a seemingly insurmountable problem. The success highlighted the ingenuity and persistence of the NASA engineers, who had to think creatively to overcome the limitations of decades-old technology. One of the biggest challenges facing the Voyager probes is their dwindling power supply. Both probes are powered by radioisotope thermoelectric generators, RTGs, which convert heat from decaying radioactive materials into electricity. Over time, the output from these generators has steadily decreased, and engineers have had to ration power carefully. NASA has implemented several energy-saving measures to keep the probes operational as long as possible. In recent years, NASA engineers deactivated a backup voltage regulator on Voyager 1. This system helped stabilize voltage and had its own small power reserve. By shutting it down, NASA could redirect the saved energy to power scientific instruments, helping ensure that Voyager 1 can continue collecting valuable data. However, this measure doesn't address all of Voyager 1's power needs, especially its aging thrusters, which use liquid hydrazine fuel to maintain the probe's orientation. These thrusters are critical for keeping the antenna pointed toward Earth, allowing data transmissions to continue. Voyager 1 initially had 3 sets of thrusters, but as it aged, these became clogged with deposits. In 2002, NASA switched to a backup set of thrusters, which was also intended for orientation control. By 2018, this second set was showing signs of wear, so NASA switched to a third set initially meant for course corrections. However, these thrusters were not designed for long-term use in adjusting the probe's orientation, and by 2024, they, too, had become clogged. In August 2024, NASA made the risky decision to reactivate the original set of thrusters, even though they hadn't been used in over 2 decades. This maneuver required powering up heaters to prepare the thrusters, which meant temporarily shutting down another component to conserve power. After a tense wait of 22.5 hours, the signal returned, confirming the thrusters were functioning again. Voyager 2 has also faced power challenges, leading NASA to make difficult choices about which instruments to keep running. In a recent conservation measure, NASA deactivated one of Voyager 2's 5 active scientific instruments, the plasma sensor. This instrument was primarily used to measure particles from the solar wind, but now that Voyager 2 is in interstellar space, the particles it would typically measure no longer flow in the same direction. This made the plasma sensor less useful, so it was chosen for shutdown. Fortunately, Voyager 2's plasma wave subsystem is still operational, enabling it to continue detecting plasma currents and turbulence in interstellar space. The energy-saving decisions made by NASA should help extend the Voyager's missions into the 2030s. As long as the probes remain functional, they will continue to send data from beyond our solar system, giving scientists a rare glimpse into the conditions of interstellar space. Even if Voyager 1 and Voyager 2 eventually stop transmitting data, their journey will not end. The probes are on a trajectory that will carry them deeper into space for millions of years. Both Voyagers carry a golden record, a kind of time capsule intended to communicate the story of humanity to any extraterrestrial life that might one day encounter them. The record includes sounds, music, and images from Earth, providing a snapshot of human civilization at the time of the probe's launch. Thanks for watching. Keep it and stay tuned. Have a good day.